In this video, I'm going to talk about R-squared in a multiple linear regression modeling framework. And as we saw in the case of a simple linear regression model, R-squared shows variation in y variable as explained by one x variable. And we're going to extend the same concept to include more than one variables on the right hand side. For example, we may have x2 up to k variables on the right hand side. And one problem with R-squared is it never decreases. It always goes up. For example, if in a linear regression model of wages, you include somebody's social security number, then R-squared will go up. Although we know that somebody's social security number have no correlation with wages. Okay, so in this first example, we are regressing college GPA on high school GPA and ACT. And if we look at the value of R-squared, it is about 0.13, which shows that both these variables, high school GPA and ACT score, they explain about 17.6% of the variation in college GPA for this sample. Okay, so here is another example of the number of arrests in 1986 of 2,725 individuals. We are interested in explaining the number of arrests in 1986 based on some of the variables. So our dependent variable is the number of arrests in 86, and these are the numbers. It varies from 0 to 12. 0 means the person was not arrested at all, and 12 means that person was arrested 12 times. We want to explain the number of arrests in terms of these four variables. The first is the PCN variable, which is the proportion of arrests prior to 1986. So this variable shows the inclination or the criminal behavior of people. So if you were arrested previously, there is more chance that you will be arrested again. P time, this shows the number of months in a prison during 1986. Again, it shows prior convictions. And this Q employment variable, it shows the number of quarters during which the man was employed in 1986. And this shows the income from legal employment. So which means if somebody was employed legally, the probability of that person's arrest will decrease. And then our fourth variable is the average sentence, which is the average sentence somebody got in a previous conviction. The first thing I'm going to do, I'm going to regress the model without average sentence, and I'm going to regress it only on PCN, the proportion of prior convictions, the time previously served in the prison, and employment from legal sources. We see that all these variables have negative coefficient values, which means they have a negative impact on the number of arrests. So here's the R-squared that we are interested in. Seems like these four variables together, they explain about 4.1% of the variation in the number of arrests in 1986. So what we can do is we can add another variable, for example, average sentence in the model, and look at the R-squared again. And this model with average sentence in it, it explains about 4.2% of the variation in the number of arrests. So seems like adding this variable is not increasing the predictive power of this model by a lot. But yet this low R-squared doesn't mean that the model is not good at predicting number of arrests in 1986, as I argued in my previous video of R-squared in the simple linear regression model. It gives us an idea about the predictability of a variable. So in this case, the model is explaining just 4.2% of the variation in the number of arrests. There are many similarities between R-squared in the multiple linear regression model and simple linear regression model, and the concept is exactly the same. So if you're confused about what this R-squared is doing, I would recommend going back to my previous video of R-squared in the simple linear regression modeling framework. Alright, I'll see you in the next video. Bye-bye.